Hello everyone. Good evening all of you.
Hello, ma'am.
Hello, good evening Prajakta. Good evening everyone. Okay, let's start. I'm sharing my screen. Tell your friends to join fast till the strength is low. Hope so the screen is visible for everyone. Yes, is it visible?
Yes, ma'am, it is visible.
Okay, let's start. In last session, we have started indexing and hashing. So in that we have learned the basic concept of the indexing. Then after that, indexing in DBMS, the structure of index, what's that? In that we have learned the search key. Search key is nothing but the copy of the primary key, and data reference. In data reference, we are storing the, it's a pointer which holds the address of the disk blocks, and disk block is nothing but the what whatever the records are in the tables, we are categorize that records into the blocks. If there are 100 records, we are creating the 10 blocks, and each block contains the 10 records. That is nothing but the disk blocks, and as starting address of that block we are storing as a pointer, okay, in the structure of the index. And the indexing is used to optimize the performance of the database by minimizing the number of disk access. So in that, there are two basic kinds of indices: ordered indices, that means it's in a sorted format, and hash indices. In that we will learn the hash function. Now there are different indexing methods, that is the ordered indices, primary index, clustering, and secondary index. We have learned these index type. Order indices means for the whatever the records are there over there, they are in a sorted format. That's why it's called the ordered indices. And the primary index, this is a one kind of ordered indices only. The primary key index is created on the basis of the primary key. That's why it's called as a primary indexing. Okay, and there is a keys are unique to each record that contains one-to-one relation between the records. Then again there are two types of primary index: dense index as well as the sparse index. In dense index, it contains an index record for every search key value in the data files to make searching fasting. But it is a if there is a small amount of record, then it's okay, dense index is okay. But if the record may goes increase, then the index file, structure index file also may get increased. So it's overload. It creates overhead on a memory storage. So to that, to reduce these drawbacks of dense index, we are again creating the sparse index. So the address issue of the dense indexing can be overcome in the sparse index. In this, the data files index records appears only a few items, and each item points to the blocks. Instead of maintaining one-to-one, we are creating the data files for a few items only, like this. We are creating the, over here see, after 3 records, we are maintaining the, over here the keys. Just 3 records indexes are stored over here for 9 records, total 9. So it reduces the overhead. Okay. So the name is sparse index. Still there is a disadvantages of sparse index. Again, if the record sizes get increased, mapping files has also grows. Because whatever is the index file is there, it is stored into the, this is the index file which is stored into the primary memory, and this one is the our actual file, which is stored in the secondary memory, and in between there are three pointers, which are pointing to the records. But if the size of the records get increased, the mapping from primary memory to secondary memory, again going to the primary memory, that is the fetching gate increase. Okay, so it consumes the time. So again there is a, to overcome that, we are there is a secondary index get invented. This is the next version of the sparse indexing. It reduces the size of mapping. For that, another level of indexing is introduced. That's why the here name is the secondary index. In this method, the huge range of columns is selected initially. Huge range of columns, thousands चा रेकॉर्ड्स आहे, तर आपण एक ब्लॉक हा 100 चा क्रिएट करतोय. तो ह्यूज अमाउंट ऑफ झाला, राईट. पहिल्यांदा इनिशियली आपण जो पहिला रेकॉर्ड आहे तो 100 चा आहे. अगेन त्या 100 रेकॉर्डचा आपण मिनिमाइज करत आहोत, 10 रेकॉर्ड्स मध्ये ब्रेक करत आहोत. दिस द प्रायमरी लेवल इंडेक्स झाला. हा ऍक्च्युअल रेकॉर्ड आहे. त्याचा फर्स्ट आपण प्रायमरी लेवल इंडेक्स मध्ये 100, 200, 300 असे ब्लॉक्स क्रिएट केले, आणि अगेन त्यांचे सब डिवाइड करून 10 चे ब्लॉक्स केले. म्हणून काय झालं, याच्यामुळे जो फेचिंग आहे ते कमी होतंय. ओके, मॅपिंग जे आहे, कारण की हे जे दोन आहेत रेकॉर्ड, दिस इज वन अँड दिस वन इज द टू, हे सेकंडरी मध्ये आहेत. ओके, सो मॅपिंग गेट रिड्यूस. प्रायमरी, then secondary. Okay, then we have seen the multi-level indexing. See, secondary is also more than one levels of indexing is there, so that's also called as a multi-level. Multi-levels means more than 1-2 index mappings is there. We are creating the index file more than 2 levels. Then here are the only two. One, this one is the first one, this one is the second. And in multi-level, there are more than 2 index files are there. We can see the index mapping growth is reduced to considerable amount, but this method also can have some problem as the table size increase. Okay, so to overcome this, we can introduce the multi-level between the primary memory and secondary memory. This method is also known as the multi-level indexing. आणखीन आपण इंडेक्स लेवलिंग हे वाढवत आहोत. सेकंडरी मध्ये 2 होते, तर मल्टी लेवल मध्ये मोर दॅन 2, 3 म्हणजे ते 3 4 असतात त्यामध्ये. ठीक आहे. The next type is the clustering index. As the name suggests, clusters, we are creating the groups. मग ग्रुप्स कशाचे करतोय, द सिमिलर काइंडचे जे रेकॉर्ड्स आहेत, वी आर ग्रुप इन टू द वन. द इंडेक्स इज क्रिएटेड ऑन नॉन प्रायमरी की कॉलम्स. आतापर्यंतचे जे ऑर्डर इंडेक्सेस आहेत, पण दीज आर बेस्ड ऑन द प्रायमरी की. But clustering index is the based on the non-primary key columns, which may not be unique for each record. Is it? In such cases, in order to identify the record faster, we will group 2 or more columns together to get the unique value and create index out of them. Yes, this is based on the non-primary key, and to identify the record faster, we will group 2 or more columns together to get the unique values. आणि एक जो आपण ग्रुप्स करतो तर त्यालाच आपण क्लस्टरिंग म्हटले. वन क्लस्टर, सेकंड क्लस्टर, थर्ड क्लस्टर, like that. This method is known as a clustering index. Basically, the records will similar characteristics are grouped together and indexes are created for these groups. Okay, जे नॉन प्रायमरी की कॉलम्स आहेत त्याच्यावरून जे सिमिलर काइंड ऑफ रेकॉर्ड्स आहेत ते आपण एका ग्रुपमध्ये ग्रुप तयार करतोय, तिथे ग्रुपमध्ये स्टोअर करतो आहोत आणि त्या ग्रुपला इंडेक्स क्रिएट करतोय. दॅट्स वाय इट्स कॉल्ड एज अ क्लस्टरिंग. सी ओव्हर हियर नाउ एक्झाम्पल. सी here, looks the diagram carefully now. Here, students studying in each semesters are grouped together. That is first semester, second semester student. The first semester students are the first semester. Second semester students are in second. Like and third semester students get students etc. is grouped into the third group. In above diagram, we can see that indexes are created for each semester in the index file. Semester 1, 2, 3, 4, up to 5. In the data block, the students of each semesters are grouped together to form the clusters. Okay. The address in the index file points to the beginning of each cluster in the data blocks, and requested student ID is then searched in sequentially. See, आता आपण जो इंडेक्सिंग अप्लाय करत आहोत तर त्याच्यामध्ये प्रायमरी की यूज केलेली नाहीये, तर आपण ग्रुपिझम केलेलं आहे. तर ग्रुपिझम करण्यासाठी काय केलेलं आहे, सेमिस्टर वाईज जे स्टुडंट्स आहेत, सेमिस्टर 1 चे स्टुडंट्स हे एका ग्रुपमध्ये, सेमिस्टर 2 चे दुसऱ्या, सेमिस्टर 3 चे तिसऱ्या, असे ग्रुप्स क्रिएट केलेले आहेत. आणि स्टार्टिंग जो ऍड्रेस आहे त्या ग्रुपचा इथे बघा, तो इंडेक्स ऍड्रेस आपण इंडेक्स फाईल मध्ये स्टोअर केलेला आहे. सेमिस्टर 1 चा इंडेक्स ऍड्रेस, सेमिस्टर 2 चा, like that we are creating the index file. This type of indexing is nothing but the clustering index. Okay, are you getting, students?
Yes, ma'am.
So we learn the different kind of indexing. Here at a glance you can see the difference between these kind of indexing. First, primary, in that there are two categories, dense and sparse, and secondary as well as the clustering. In the index wise there is a difference, is that in dense it is created on the most of the column of the tables. In sparse, it's created on the range, on group of column values, mostly on primary key. Okay, and in dense there is a one-to-one relation, and in secondary it's created on the range of the group of column values, mostly on the primary key only. But there are two levels. And in clustering, it's created the index on the group of value non-keys column. Just we learn this thing. Okay, non-key means it's not depends on the primary key column. Then level, how many levels are present in the dense? Single. In sparse, again single. In secondary, yes, it's more than one, that's why it's a multiple. And in clustering, again it's a single level indexing. Then in the dense, how the data is stored? Yes, it's a sorted one. Dense part sorted, secondary again sorted, as well as in clustering data is sorted one. Then advantages, dense, we faster search in a smaller tables. This is the advantage, and this is the easier one. Again, dense and sparse, the advantages are same. In secondary, as we are creating the more levels, so it's better performance in a bigger tables too, it gives. Then in clustering, here is a clean grouping of the record and hence better performance. According to the similarity, we are grouping, we are creating the groups. So it gives the better performance. And again, there are some disadvantage of each kind of indexing. A dense and sparse indexing are not suitable for larger tables, as the tables grows, performance degrades. In secondary, as the level increase for the larger tables, the performance again degrades. And clustering, unused memory space needs proper memory management. Because here, see why it's unused memory, uh, it may get wasted. See, whatever we are creating, these blocks are fixed in size. Okay, so each block has the 10 number of records. Assume that may store the 10 number of records. But currently we have only 5 records. Then the next 5 records memory get waste. So that's why here we can say that unused memory space needs proper memory management. This is all about the indexing, primary, secondary, and clustering. Now, let's move to the next point, that is the binary tree. Yes. Do you know the binary tree? What's that? Anyone? Have you heard the word binary tree?
Yes, ma'am.
That's good. Yes. Tree. Tree is an organized data structure for the storage and retrieval of the data. So, in hierarchical format, we are storing the data. That's why it's called as the tree structures. And in that, binary tree is nothing but if there is a root node, then it has, for each node, it has max 2 children's. Okay, left hand side and right hand side. That's why its name is binary. That is the 2. Here see the binary search tree structure, and assume this one is there. Now over here 7 is the root node, then whatever the values on left hand side, these are the less than root node, and right hand side nodes are greater than the root node. Okay, why it's needed? Because suppose you want to find out 11 in binary search tree, how it's going to find out the binary tree? First we came to the 7, that is the root node. Then by algorithm we can change whether it's greater than 7 or less than 7. Of course it is 11 is greater than 7, so we are going to the right hand side. And this one part get vanished from the search. ट्री मधून व्हॅनिश होत नाही, आपण जो सर्चिंग करतो आहोत त्यामधून तो इलिमिनेट केला जातो. हा सर्चिंगला आता घेतला जात नाही. सो वी कम टू द ओव्हर हियर नाउ value 11 will check with 17, whether it's greater than or less than. It's less than 17 though, so we move to the left side of the 17. Now checks 11 with 1. Yes, 11 is equal to 11, and we will found the node. In this way we can finding the record using the tree or binary tree. Okay, now the main motto to revise the binary tree, because we have to learn now binary B plus tree index file. Okay, this terms is related to the data structures. Okay, now binary B plus tree index files. This is the nothing but its balance binary search tree. B plus tree is the balance binary search tree. it follows a multi-level index format. You know now the multi-level index format. We just revise the multi-level index format. There are more than 2 indexing level index files are we are creating. And as the level goes increase, we are creating the index of index. Index files as again we are creating the index file, again index file, like that. So in the B plus tree, leaf node denotes the actual data pointers. See, yes, B plus tree is the balanced binary search tree. This structure is logically depends on the binary search tree, but it's in a balanced one. Why it's called it's balanced? Because if you see over here the leaf nodes are over here 3, 9 and 13s, but all these are at the same level. No, not at all. They has different levels. If we say the root on level 0, 7 is at 0 level, then 4 and 17 and level 1, 3 which is the leaf node at level 3, and 9 and 13 are 3 is at level 2 and 9 and 13 at level 3. Okay, so these are in binary search tree. It's not a balanced tree, but the B plus tree is balanced binary tree, means all the leaf nodes are at a same level, So leaf node denotes actual data pointers, and B plus tree ensure that all leaf nodes remain at the same height. म्हणजे जे काही लीफ नोड्स आहेत शेवटचे ते त्यांची जी लेवल आहे रूट नोड पासून ती सेम आहे, आणि ऍक्च्युअल डेटा कुठे स्टोअर असतो? लीफ नोड मध्ये. So in the B plus tree, the leaf nodes are linked using linked list. Therefore, B plus tree can support random access as well as the sequential access. Okay. As we know that linked list is a non-linear kind of non-linear data structures. There is a no sequential access. We can access any data from anywhere randomly because it's a non-linear. So let's see the structure of B plus tree. In the B plus tree, every leaf node, जो शेवटचा node आहे, शेवटचे, is at an equal distance from the root node. This is the one of the most main concern. That's why it's called a balanced binary search tree. The B plus tree is of the order n, where n is a fix of every B plus tree. Suppose तुम्हाला काही प्रॉब्लेम दिला तर त्याच्यामध्ये त्यांना n हा द्यावा लागतो, which is fixed for every B plus tree. म्हणजे लीफ नोड मध्ये आपण किती रेकॉर्ड स्टोअर करणार आहोत ऍट अ टाइम? 5 आहे, 6 आहे, तर तो त्याच्या ते n वरून ठरतं. It contains an internal node and the leaf node too. Student, is there any doubt? Let me know. Okay. Then internal node. It contains the internal node and the leaf node. See over here now. This is the structure of the B plus tree. This one is the root node. These are the leaf nodes. This one, leaf nodes. and in between root node and leaf node there is a internal nodes. Okay, and actual data is stored at the leaf node in a B plus tree. See, this is your actual table. Okay, now internal node. An internal node of B plus tree can contain at least n by 2 records pointers except the root node. किती असतील त्याच्यामध्ये at least n by 2 records, and each node that is not a root or leaf node has a n by 2 and n children pointer, and at most the internal of the tree contains n pointers. N pointers means n child. You can say pointers or child. सपोज इथे तुमचा 4 आहे, n हा 4 आहे, तर इंटरनल नोड्स किती असतील at most n by 2. ओके, हे काय झाले 2 झाले. And leaf nodes, the leaf node has between n minus 1 divided by 2 and n minus 1 values. Okay, इथे अज्युम करा की या स्ट्रक्चर बी प्लस ट्रीचा 5 आहे. ओके, n, तर इथे इंटरनल नोड्स n by 2, इंटिजर व्हॅल्यू किती झाली 5 by 2, 2 झाली ना, त्यामुळे इथे इंटरनल नोड्स हे 2 असतील मॅक्स, आणि लीफ नोड्स काय आहेत इन बिटवीन n minus 1 by 2 and n minus 1, म्हणजे मॅक्स हे 4 असतील आणि मिनिमम 2 तरी असणारच. ओके, हे लीफ नोड झाले. and every leaf node of B plus tree contains one block pointer P to point the next leaf node. See, लीफ नोड्स मध्ये आता मिनिमम 2 रेकॉर्ड्स असतील आणि मॅक्सिमम 4 रेकॉर्ड असतील, राईट, कारण की आपले n हा 5 आहे आणि इथे हा ब्लॉक पॉइंटर आहे ऍट द एंड ऑफ द नोड which point to the next node. It holds the address of next node. See, see this arrow. Here again. Okay, see, again I'm revising the internal node as well as the leaf node. Each node that is not a root or leaf node has in between the n by 2. Okay, and n is nothing but the children, n children or pointers, and leaf nodes are the nodes has between leaf node किती असतील n minus 1 divided by 2 or in between आहेत ते n minus 1 value असेल. Okay, now here is the example of the B plus tree. Suppose B tree, for an instructor file here n is given, that is the 6. So leaf node must have between the 3 and 5 values. Why is it so? Because leaf node should be, or it's a rule, n minus 1, 5 divided by 2, that is the, that is it, at least the 3 to n minus 1, that is the 5, that's why it's a 3 to 5. And non-leaf nodes other than the root must have between the 3 and 6 children. Okay, and root must have at least 2 children. This is the basic structure of B plus tree. Now, how to search the record in the B plus tree using the indexing? Suppose we have to search 55 in the below B plus tree structure. What to do first? Huh? We will fetch the intermediately node, which will be direct to the leaf node that can contains a record for a 55. We will fetch first intermediate nodes, we will search over here and fetch that one. So 50, there are 25, 50 and 75. So 55 come in between the 50 and 75. So we fetched for first intermediary nodes, 50 and 75. So intermediate nodes will find in the branch between the 50 and 75. And then at the end, we will be redirect the third leaf node. Here, DBMS will perform the sequential search after getting intermediate node. And in that, we will find the, after sequential search, we will find 55 at second search. Okay. In this way, we can search using the B plus tree. Okay. Now B tree index file. Yes. Yes, B tree is similar, quite similar to the B plus tree, but it's, yes, there is some difference. B tree indices are similar. The primary distinction between the two approaches is that B tree eliminates the redundant storage of a search key values. Redundant storage of a search keys value. How? How it B plus tree is redundant? We will see that one too. In a B plus tree, what is happening? The leaf node, whatever the leaf nodes are over there, for every search key value, whatever is in the leaf node, it appears in a some leaf node and several are repeated in a non-leaf node. See, B plus ट्री मध्ये तुम्हाला सगळा रेकॉर्ड्स कुठे मिळतो? जो ऍक्च्युअल रेकॉर्ड आहे तो कुठे असतो? लीफ नोड मध्ये स्टोर असतो. ईच अँड एव्हरी जो तुमचा ऍक्च्युअल डेटा आहे, सी ओव्हर हिअर, हा जो तुमचा आहे रेकॉर्ड सगळा, तो कुठे स्टोर केलेला आहे? सी प्रॉपरली, ईच अँड एव्हरी रेकॉर्ड इज स्टोर्ड ऍट अ लीफ नोड. मग हे जे नॉन लीफ नोड्स आहेत, internal nodes, these are the copies of the leaf node. See, Einstein, non-leaf node, first one internal node, which is again present in the leaf node. Gold, this is also present in the leaf node. Means some leaf nodes are repeated in a non-leaf node, that is the internal nodes. That means it creates the data redundancy in a B plus tree. So B plus tree store, just wait. So B plus tree stores the data such that each node contains key in ascending order. Just wait. Yes, B tree is a data structure that stores the data in nodes and sorted order, and it can represent the sample B pluses as follows over here. Hmm. Where is this? And each of these keys has a two references to another two child nodes. Okay, and left child nodes keys are less than the current keys as we learn the in a binary tree. Same आहे, similarities आहेत. फक्त काय आहे की बी ट्री आणि बी ट्री प्लस ट्री मध्ये तर जी काही रिडंडन्सी आहे बी प्लस ट्री मध्ये ती अवॉइड केली जाते युझिंग बी ट्री. Okay, in a B tree, the leaf nodes of every search key value appears in a some leaf nodes and several are repeated in a non-leaf nodes. हे आपण बघितलं B plus tree मध्ये आहे. A B tree allows search key values to appear only once. जे non-leaf nodes मध्ये होत आहेत रिपिटेशन्स तर ते आपण बी ट्री मध्ये अवॉइड करत आहोत. Unlike B plus tree, where a value may appear in a non-leaf node in addition to appearing in the leaf node. This is the main difference. It avoids the redundancy of the data. See now, see, look over here. This is the B plus tree. These are the internal nodes. First one is the root node. Then these are the internal nodes and these are the leaf nodes. And internal nodes are the duplication of the leaf node itself. But using B tree, we are arranging the record one more times and avoiding the redundancy. See, here, whatever are the non-leaf nodes, these are the repeated in B tree, B plus tree, and here we are avoiding that redundancy. And this is the difference between B and B plus tree. In the case of B tree, the leaf nodes include the data pointer, and in the B plus tree, only the leaf nodes includes the data pointers. See over here. Here and here. See. But as B tree avoids the non-leaf nodes, here the insertion may take longer time, and here the insertion is easier and faster than the B tree. Okay. And in the B tree, there is a no duplicate of key sustained in the tree, but in the B plus tree, duplicates of the key are maintained. And again, insertion as well as the deletion in a B tree is complicated. But in a B plus tree, deletion is easier. Though there is a redundancy of record, it provides the insertion and deletion process easier as compared to B tree. And in a B tree, there are no redundant search key available, but in a B plus tree, redundant search keys are available. And in a B tree, the B all the leaf nodes are not saved as a structured linked list, but in B plus tree, all the leaf nodes are stored in a structured linked list. This is the main difference. These are the main difference between the B and B plus tree. Okay. This is all about the B plus tree. These are the two different types of the multi-levels indexing. So today we are stopping here only. Any query? Attendance, please. CR of the board division are available? Yes.
Yes, ma'am.
Send me the screenshot of B division as well
Okay,
as
ma'am.
A division. CR, are you there?